Let me share my screen. Yeah. Okay. Thank you very much for participating in this lecture. So today's lecture is on, does smart transportation matter in inhibiting carbon inequality? So this study was a joint study done by myself and my colleagues from Beijing Technology and Business University, and also University of International Business and Economics of China. So this study was published in the Energy Economics Journal, and it is now available. So if you want to read more about it, please download this paper and read it. So first of all, as it is clear from the title of this study, we aim to assess the impact of smart transportation on carbon inequality. So you are familiar with smart transportation, and in many countries, including in China, many automakers are promoting smart transportation, and the transportation sector in public transportation, and also especially in the private owned cars, are becoming more smart when we compare it to a few years ago. And many automakers entered to this industry and using and utilizing different technologies for having more smart automobiles. But what is carbon inequality? So let me define carbon inequality. Carbon inequality refers to the uneven distribution of carbon emission and their associated impacts among individuals, communities, and nations. So when we have income disparity and income inequality, we also have carbon inequality and carbon disparity. So some entities or regions contribute more to carbon emission, while others bear a disproportionate burden of the consequences, despite often having lower contribution to the issue. So this concept underscored the need for equitable and just solution in addressing climate change. So if we want to have if we want to achieve carbon neutrality, and if we want to have a more sustainable societies, we need to solve not only the carbon emissions need to be reduced, but also the carbon inequality as a whole also need to be solved. So despite the fact that the world and China are actively addressing the issue of carbon emission and climate change, they are also facing another phenomenon that called carbon inequality, or CI, that the eradication of which is also crucial for achieving sustainable economy and sustainable societies. So as a low carbon, on the other hand, as a low carbon, energy saving and sustainable transport development mode, smart in transportation has attracted increasing attention, not only by industry, but also by academia, and many researchers have focused on it and studied this. So promoting the development of smart transportation is crucial in the process of accelerating the coordinated development of the regions, especially for cities that have lower economic growth and lower industrial level. So that would effectively improve the efficiency of energy utilization, and it upgrade the industrial structure, therefore promoting the energy transition. So when we reviewed the literature, we found out that some scholars explored the issue of global carbon inequality from the perspective of international trade and pointed out that embodied carbon emission in developed and developing countries are unequal. However, we have found very few studies that have focused on the CI issue within regions and provinces. So because of that, because of this gap that we have found in the literature, we started to do this research, and this research project was aimed to mainly answer and address the following research questions. So first of all, to what extent and how does smart transportation affect carbon inequality? Secondly, we aim to answer to this question that to what extent can the development of smart transportation contribute to carbon inequality inhibition? Next, what are the heterogeneous effect of smart transportation on carbon inequality? What is the direct impact of each dimension of smart transportation on carbon inequality? What are the internal impact mechanisms through which smart transportation affect carbon inequality? So in this study, we aimed to have these three contributions to the literature. So first of all, quantitatively and accurately measuring the specific level of carbon inequality in each province using the tail index method and provide new insights and technical references for studying the topic of carbon inequality. Secondly, examining the impact of smart transportation and carbon inequality based on an econometric model. So we use the generalized method of moments, and which can help the policymakers to formulate policies from the aspect of smart transportation to eradicate carbon inequality. Next, decomposing the smart transportation indicator system into multiple aspects, because when talking about the smart transportation, there is one infrastructure, there is the technical parts of it, and many other parts that need to be considered. So we cannot just consider smart transportation as a whole. So in this research, not only we consider the smart transportation as a whole, but also we decomposed smart transportation into different parts in order to assess the impact of different parts on carbon inequality reduction. So this figure shows the different types of analytical works that we have done in this research. So first of all, we have used the tail index in order to measure the carbon inequality in different parts of China. Next, we have done static and dynamic econometric models in order to do a nexus analysis between smart transportation and carbon inequality. This is our baseline regression. Next, we have included industrial structure and consumption level in order to check the heterogeneous analysis. And on the other hand, we have developed a GMM model in order to consider different aspects of smart transportation, including supply, consumption, service affordability, infrastructure efficiency, and technology. And by running this model and running this regression, we could be able to understand impact of different aspects of smart transportation on carbon inequality. Next, we have done a mediation effect analysis in order to understand the channel of transmission of smart transportation to carbon inequality. So in order to find the mediating variables, whether energy consumption or carbon emission efficiency have the mediation impact or not. So these studies, we have done these analytical works in order to find out the impact. And before running our regression, we have done a comprehensive literature review. So many scholars, including Wang et al., have examined the issue of carbon inequality on a global scale, focusing on international trade dynamics in order to find out the impact of trade and economic integration on carbon inequality. Or another study by Wang et al. Scrutinized carbon inequality in 6 regions. They revealed asymmetrical losses and gains in CO2 exports and added value, notably in Asian countries. Another study, Wang et al., find the Belt and Road countries exhibit better carbon inequality performance than global average. Another study by Zhu et al. That use an MRIO model to show a mismatch between embodied CO2 emission and value-added commodities in trade. Another study by Mi et al. Measured the carbon inequality in China using the Gini coefficient, emphasizing a more severe carbon inequality dilemma in developed Eastern area, especially in the context of income disparity. Or another study by Wiedenhofer et al. Used Gini method to reveal how household carbon footprint, carbon inequality, identifying that the top 5% of income earner as a significant contributor to CO2 emission. Or another study by Wang et al. 2022, verify the linkages between income inequality and carbon inequality in Japan, expanding insight into carbon inequality across different countries. Xu et al. Investigate prefecture-level carbon inequality in China, identifying income and energy-intense disparity as factors affecting carbon inequality, while investment and industry disparity worsen this situation. Another group of studies that we have reviewed in the comprehensive literature survey is on smart transportation and its social economic impact. So the advancement of technology has led to a series of positive environmental and economic impact of smart transportation, as emphasized by Abu Khadra et al., who underscored the significance of contributing technology in smart transportation. Or Ushakov et al. Focused on the role of Internet of Things and big data in smart transportation, finding that technology-based smart transportation positively contribute to the prevention of traffic accidents and their real-time monitoring. Xu 2022 highlights the indispensability of Internet of Things and sensor devices for the popularization and application of smart transportation, further reinforcing the technological foundation of a smart transportation. Another study, Young et al., quantitatively evaluate the social and carbon mitigation effect of smart transportation, revealing that the smart transportation inhibits total exhaust emission and pollution. So we also continued and we reviewed a more extensive literature on smart transportation. Haley et al. Assert the crucial role of smart transportation in achieving smart city status, emphasizing its positive impact on connectivity among cities and regions. So there are also several other studies. Karami and Kashef argue that a green and a smart transportation model is essential for a low carbon sustainable future, aligning with the broader environmental goal. Or Karim 2022 highlight smart transportation significance in enhancing efficiency in urban and highway transportation system, stressing its role in traffic security and privacy. Additionally, Chin et al. Explore influencing factor for smart transportation development, noting its more prominent effect in big cities due to severe traffic congestion, ultimately contributing to improve efficiency and accuracy in traffic operation, reduce congestion, and a more sustainable energy profile for the transportation system. So it's always important to do a literature review before running the estimation and before running our model, since it would clarify and reveal that what gaps this study aims to fill. Yeah. So because of that, we also did same. So next we have, as it is clear in these slides, it shows the gaps that we filled, this research field, and aim to fill. So although review of the literature shows that some scholars explore the phenomenon of carbon inequality and its relationship with industrial trade, international trade, income, and aging, however, we have found few studies that document the nexus between carbon inequality and smart transportation. And no research have found to explore the heterogeneous relationship between a smart transportation and carbon inequality. Therefore, how smart transportation affects carbon inequality remains unexplored. And also, we couldn't find any study that decompose smart transportation and assess the impact of different components of a smart transportation on carbon inequality. So because of that, this decomposition would give insightful policy implications. So this is the general model that we have. The dependent variable is carbon inequality, and the main explanatory variable is ST or smart transportation, as you see here, ST or smart transportation. We also have 4 control variables. Control variables are 1, economic development, as denoted by GDP. The proportion of output value of tertiary industry to total industry, that denoted by SER. Government fiscal expenditure, denoted by GE. And residential consumption structure as a whole, that denoted by RCS. And in this study, we collected the data of 30 provinces in China and the time period from 2002 until 2017. To eliminate the possible heteroscedasticity issue, we take the natural logarithm. So all variables are in logarithmic form, and we have the fixed effect component here, as it is clear by fixed effect relating to individuals, and also the fixed effect relating to another. So that is provided here. Next, regarding the definition of the dependent variable, as I've mentioned earlier, the dependent variable is carbon inequality. But how we measure this? How we measured it? So as the dependent variable may have autocorrelation, before I explain about it, this is important to mention that in order to cope with the possible autocorrelation, we included the lagged variable, lagged of dependent variable as one of the explanatory variable. So this means our model is GMM, system GMM we have used. And this became the econometrics model that we used our baseline regression using GMM based on it. And the aim is to assess the and find the sign and magnitude of each of these coefficients from beta 0, that is the constant, beta 1. Beta 2 is the most important coefficient that shows the relationship between smart transportation and carbon inequality. So as I've mentioned earlier, we have used the tail index based on generalized entropy method in order to calculate the carbon inequality. So tail index is widely used in order to assess the inequality of income, inequality in expenditure, in wealth, in education, in energy, in environment. And there are extensive literature based on that. So because of this, we also, because it is very common and it's a conventional way to calculate the inequality, we also use the same method. That here WI is the population weight for each province. CO2 is the carbon emission in each province. Min CO is the mean carbon emission for all provinces. Core independent variable is a smart transportation. Is measured by constructing a comprehensive indicator system consisting different aspects of smart transportation, including supply of a smart transportation, consumption, system affordability, infrastructure, efficiency, and technology. So the indicator system as well as the data of a smart transportation come from Zhao et al. So on one hand, when we checked the development of smart transportation in different provinces in China, we found out that Guangdong has a leading role of smart transportation in China, while some other provinces in western and central parts of China are lagging behind. On the other hand, the overall level of smart transportation showed progress when comparing from 2002 until 2017. As it is clear here, Guangdong from 2002 was the first prefecture. Even now, it's the first prefecture. At that time, just Shanghai, Beijing, Guangdong were among the top, but now Jiangsu, and as it is clear here, Shandong, Beijing. So these are growing and among the top. On the other hand, other provinces and prefectures are also experiencing progress, but some provinces in the western part of China and central part of China are lagging behind. Next, let me show you the first regression. So the first regression, as it is clear here, this is the most important coefficient. So we have done 5 regression. The first one is just considering the relationship between the explanatory variable and the dependent variable. Then number two, we added one control variable, GDP. Number three, we added government expenditure. And in number four, we added another explanatory variable, which is the share of tertiary industry. Next, we added the residential consumption as the last control variable, and regression 5 shows the most complete regression. As it is clear here, the association between smart transportation and carbon inequality is negative. So this means that by increasing the smart transportation, by expansion and development of a smart transportation in all prefectures of China, the carbon inequality diminish. And yeah, so this is important finding. We have used, as I've mentioned, we have used system GMM as a baseline regression method, and step-by-step regression is conducted. So the lag term of CI and the EI is included only in, as I've mentioned, in column 1. And then in column 2 to 5, we added the control variables. Step-by-step result from the last column shows that the coefficient of lag of CI, so this variable, the lag of CI, so this one is 0.91. What does it mean? It means that the CI in the last period has an aggregate effect on the CI in the current period. So this is important. Next, we found out that the coefficient of smart transportation is negative and remains significant at 1% level, no matter whether control variables are entered or not. So this means that even when we included the control variable, the marginal effect of ST on CI is 0.119, indicating that for a 1% increase in smart transportation can trigger a decrease in carbon inequality by 0.1%. On the other hand, we found out that increase in GDP also significantly increased the carbon inequality by 0.04%. If government increased the fiscal expenditure by 1%, the carbon inequality can be reduced by 0.2%. For robustness analysis, we have changed the control variables. In the first column, we replace the proportion of the output value of tertiary industry to total industry with the ratio of value added in the tertiary industry to that in the secondary industry. Again, as it is clear here, the sign and coefficient of the coefficient of smart transportation doesn't change, and still the relationship is negative. And it is significant. Next, in the second column, we replace GDP with GDP per capita. And as it is clear here again, the sign and significance of the smart transportation coefficient didn't change. And in the third, we replace the residential consumption structure with the total volume of residential consumption. Again, the sign and significance of smart transportation coefficient didn't change, so it means results are robust and there is a negative association between a smart transportation and carbon inequality. Next, we have checked the heterogeneous effect analysis. We have done the heterogeneous effect analysis. So in this table, in table 4, the 4 columns represent the high industry structure, low industry structure, high consumption level, low consumption level. And as it is clear here, the coefficient of smart transportation in column 2 and 4 are negative. So what does it mean? It means in those prefectures that the level of industry is low or the level of consumption is low, the association between smart transportation and carbon inequality is negative. So it means in western parts of China or in central parts of China, if government promote the smart transportation, we expect that it has more impact on reducing the carbon inequality. However, in those prefectures that there is a high industry structure or high consumption level, the sign is positive. Why it is happening? Because there are many drivers for carbon inequality in those regions, and just smart transportation is not enough. And at the same time, many other policies needs to be taken in order to solve the issue. Next, we have decomposes. Decomposes the smart transportation, as I've mentioned earlier, to 6 different aspects. What we found is that the coefficient of transportation infrastructure is positive, and more development of transportation infrastructure positively impact the carbon inequality. However, this might be in the in the short run, but in the long run, it's possible that this association, the relationship between these two become negative. While all other coefficients for the sub-indicators or the components of smart transportations are negative. The most significant one is transportation technology. So it means government needs to promote the technologies that can develop more, smart transportation. Maybe private sector does not show enough interest for investment in R&D of technologies related to a smart transportation. So government needs to promote this sector. So next is the indirect. In order to find out that what are the mediators, we have included the energy consumption, and we have also included the carbon emission efficiency. Carbon emission. So as it is clear here, the coefficient of a smart transportation is minus 0.08 in the first column, indicated that for every additional increase of a smart transportation, the energy consumption would reduce by 0.08%. Then an increase in energy consumption by 1%, as it is clear in the second column, would increase the carbon inequality by 0.01%. So this means that one mediator is total energy consumption, and more development of smart transportation can reduce the energy consumption, and reduction in energy consumption, it means reduction in carbon inequality. Next mediator variable that we have included is carbon emission efficiency. So development of smart transportation can increase the carbon emission efficiency more. And then, as it is clear here, so results show that 1% increase in a smart transportation would increase the carbon emission efficiency by 0.03%. An increase in the carbon emission efficiency would reduce the carbon inequality by 0.0004%. So this shows what we have found. In the left-hand side, we show the direct impact that the supply of smart transportation, consumption of a smart transportation, infrastructure, service, this should be technology, service affordability, and this would have negative impact on carbon inequality and would reduce the carbon inequality. But on the other hand, this infrastructure would have the positive impact. Then on the right-hand side, indirectly, smart transportation development would reduce the energy consumption, and reduction in energy consumption would change the carbon inequality. On the other hand, smart transportation development would enhance the carbon emission efficiency, and carbon emission efficiency increasing would reduce the carbon inequality. So let me repeat again, smart transportation development would reduce the energy consumption, and reduction in energy consumption would reduce the carbon inequality. So this relationship is positive. It means if energy consumption increase, carbon inequality increase. And if carbon emission efficiency increase, carbon inequality reduce. So let me conclude this study and provide some policy recommendation. This study empirically investigates the relationship between smart transportation and carbon inequality using the data of 30 provinces in China from 2002 until 2017. What we found in this study is that the development of smart transportation has a demonstrable alleviating impact on carbon inequality, as evidenced by our baseline regression, encouraging the proportion of smart transportation proves effective in inhibiting the inequality of carbon emission, a finding validated through robustness check. Next, the nexus between a smart transportation and carbon inequality is more pronounced and notable in provinces with comparatively lower level of industrial structure and residential consumption. Third, we found out that transportation infrastructure play a significant positive role in exacerbating CI, while other sub-indicators, especially transportation technology, would reduce the carbon inequality. Furthermore, we found out the mediating role for energy consumption and carbon emission efficiency. This means that development of a smart transportation would reduce the energy consumption, and a reduction in energy consumption would reduce the carbon inequality. On the other hand, we also found out that the development of a smart transportation would enhance the carbon emission efficiency, and enhancement in carbon emission efficiency would reduce the carbon inequality. And these are the, the policy implications of this research. So the policy implications of this research are enhancing development of smart transportation, the development of a smart transportation, utilizing modern technology like the Internet of Things, big data, would significantly reduce the carbon inequality. Governments' effort to actively enhance smart transportation development, accelerate national transportation network construction, and promote pilot projects can drive intelligent and modern transportation. Another point is tailored policies for local development. Governments should formulate targeted policies for smart transportation development based on regional disparities, considering unique local industrial and consumption structure. Regions in transition should receive additional resources for smart transportation infrastructure construction, and attention should be given to social benefit and the value that it creates. Next is focusing on transportation technology innovation. Transportation technology among smart transportation sub-indicators exhibit the most significant impact on reducing carbon inequality. So it means innovation in a smart technology, smart transportation technology, such as integration of AI, video cloud, big data, and Internet of Things in a smart airports can notably improve operational efficiency. And finally, addressing energy structure and emission efficiency. Government's initiative should not only focus on transforming the governance structure of smart transportation, but also on improving energy structure and carbon emission efficiency. Construction of smart cities coupled with a smart transportation development can reduce overall energy consumption and enhance the smart transportation efficiency for a highly in order to reduce the carbon inequality. Thank you very much for your attention. I hope today's